All right, let's give this a go. Hello, everybody. Good morning and good afternoon, depending on wherever you may be. Thank you for joining the Elastio webinar today. Today, we're going to talk about anti-ransomware protection for backups, specifically in the context of business continuity and compliance. And today, my name is Todd Frederick, and I will be your host. But are joined here by today's speakers, Dr. Srinivas Vajaharian and Sabithan Kalpathy. From AWS and Trinity from Elastio. So let's go ahead and get started with a little bit of a background. So I'm sure everybody's somewhat aware that ransomware today has really become a pandemic. It's one of the hot topics in most boards and most organizations that we talk to, and lots of money and lots of activity are being spent to prevent it from entering into the organization. But it's increasing year over year. And if you just look over the last 12 months, 85% of organizations have expressed some form of attack or vulnerability in their systems. And it's very scary because 25% of the organizations that actually do pay the ransom don't get their data back, and it's somewhat of an issue there. And we can see time and time again that the backups, which is your last line of defense, are one of the first things that are attacked, with 75% of the backup repositories are affected by a ransomware attack. I think what's other interesting data point, as opposed to just reading through this list here, is if you look at it, 56% of backups risk reinfection when you go to recover. And if you look at what the market has really tried to do over the last year, it's really about air gapping and making the backup vaults immutable. And we're going to talk a little bit about that today, how you do that with the AWS backup team. But one of the things that's insidious is that ransomware is always evolving. Ransomware is always trying to figure out how to get around and to bypass various security measures. It's a living, breathing, business that's out to steal yours. And one of the new attack vectors is to hide undetected in your data and compromising your backups over time by being backed up into your immutable and air-gapped backup system. And so when a full detonation takes place, you're really left defenseless, having reinfecting the data when you restore. And so you end up in a situation where your backups aren't enough to recover your data, leading to long downtimes and data loss. And these are just things that in today's environment are the worst nightmare for CISOs, systems managers, data protection professionals, et cetera. Elastio was built to kind of address and to cure the ransomware effect, and we'll have Dr. Srinivas Vajaharian walk through a unique way of approaching that. Essentially, what we are able to do is detect ransomware encryption in backups and live data with a high degree of accuracy. We automatically direct you to the last known good, clean backup prior to an infection taking place to ensure that clean recovery, and continuously discover and protect backups. So as new backups come online or new workloads are added, automatically detect them and put them under a security policy. Just by way of background, Elastio was founded by a series of storage and data protection professionals with an emphasis on security as well. So as we continue to go through this, backups have become so important that they are now subject to regulation. And if you look at this, here are three of the major regulating bodies that talk about specifically how to protect backups, how to protect your data. NIST was just updated. I'm sure that's the framework that we all focus on here in the States, that the integrity of backups and restoration assets need to be verified and tested before restoring. That's kind of a critical path if you think about it, making sure that reinfection does not take place. But for our friends overseas and any companies that are doing business overseas, DORA, Article 12, does something very similar. Procedures need to be backup and recovery procedures need to be well documented. They need to be scanned for what's in the contents. They need to be complete, and they need to be recovery tested on some sort of periodic basis. And those recovery tests and their results need to be posted. Similar with NYDFS, that's the New York Department of Financial Services. They have, their cyber resiliency code, Part 500, really talks again about any company, financial or insurance, that does business in New York What policies do they have around their backups and recoveries? Are they scanning it? Are they performing backup tests? Do they have a recovery test in plan? Can they demonstrate this? And you combine that with the ever-increasing cyber insurance, posture to make sure that all this stuff is being documented. There's never been more of a focus on your backup and disaster recovery plan, and making sure you understand what's inside of those backups is becoming more and more critical and recognized by these governing bodies. With that, I'll actually turn it over to Srinidhi, and he'll walk through the technology stack and how we are able to identify these new threats. Srinidhi?
Thanks, Todd. So before I begin, I want to just set the sort of landscape for security defenses that most companies already have in place. So if you look inside any modern infrastructure, the very first thing almost everybody has got is some form of EDR or XDR or antivirus solutions running on the endpoint. And these are directly running with agents on the system, being the first line of defense effectively for attacks that are coming in. But the history is unfortunately not that great, and EDR and XDR systems constantly get bypassed. There are several fairly sophisticated bypass techniques available in there. For example, there are two classes of kind of hooking systems in there, and people do a combination of one or the other. You end up hooking onto NTDLL, which is the bottommost layer that calls inside Windows. Or you hook into the logging libraries, essentially ETL subsystems in there. And bypass techniques exist for both of them. NTDLL, there are side loading techniques as well as techniques by which you can get yourself a clean copy of NTDLL from another side running process, which effectively bypasses on a per process basis. And this is fairly common. So EDR, XDR, assuming that it is the only line of defense is not a great one. For ETL systems, similarly, you have ROP programming techniques, return-oriented programming, wherein you can make it appear that the bad stuff you're doing is happening inside some other trusted library, like NTDLL. And so it's very hard then if you do any kind of stack analysis to figure out like what is actually happening in there. And so you bypass the event. NTDLL is trusted, so you don't emit the event that you're supposed to be emitting. So these hiding techniques are what enable bad actors, essentially the loader stages, to be dropped as a payload effectively onto a system. And at this point, you're now running blind, essentially. EDR systems have been deployed in all of the major attacks that actually happened over the last year, unfortunately. And this is exactly what would happen on the right-hand side. There'd be some kind of web rack sitting in there that now gives the attacker the ability to remotely control your system. Next slide, please. So EDR, XDR itself forms, as I said, the first layer of defense. And effectively, any modern defense architecture is multi-layered. So we should look at them through all the layers in there. So at the very end, you've got your firewalls, your network protection, and your endpoint detection and response or extended detection and response systems in there. And the problem is typically they get unhooked, but they usually face a fairly large swath of attacks coming at them. And so they're very important first line of defense. They should not be ignored. Then you get deeper into the infrastructure. After EDR, XDR bypass, other folks might have application security layers that do vulnerability management, patch management analysis. There might be software bill of materials checks that happen, and CSPM systems that look through everything from network onwards to patch levels to automation. So as an example there are several companies that operate in this space, but they also get bypassed very similarly once when someone is there. And when that happens, you end up in the data. That's your last line of defense, and your data is sitting inside your backups. So the question is like, who's looking to make sure that something is not ending up, bad stuff is not ending up in the backups? Malware, either in the form of binaries or initial stages from PowerShell. What if the stuff in there has been getting encrypted from your end host and you weren't seeing it at all? There are malware attacks that actually do that. So that's exactly where Elastio plays. We check the integrity of all your backups that are coming in. We also have the ability to directly snapshot VMs like EC2 instances and scan the workload itself instead of having to go through a backup engine. So we are an agentless system. We operate directly, as I said, on backups, and we do some fairly deep analysis in order to find ransomware inside that. And I will describe what they do, what we do in there from a technology perspective. Next slide, please. So essentially, the sort of the state of the art generally for trying to detect stuff in here, and most backup vendors have this capability, is some form of anomaly detection. So your anomaly detection is, these are crude metrics typically. Things like my backup is bigger than normal. Historically, my snapshots used to be this size. Now, why is my snapshot suddenly bigger? One reason for that might be that a ransomware detonation happened and a bunch of stuff got encrypted, so your snap is bigger. Another could very well be that your application stack in there did an update, and the update files were in there, and thus the backup snap is bigger. And the latter case is more common, unfortunately. So you end up with a lot of false positives and you have to threshold. We took a different approach. About 3.5 years ago or so, we started actually looking at the original source of the data, which is go and pick up samples of every ransomware ever written since 2014, reverse engineer it, cut it off from command and control servers, and perform a controlled detonation. Some of these things are very tricky because they require other side CNCs to be operating, they have timing to them. So you have to be able to neuter that portion off to be able to even see what it actually does. And then detonate it. And from that, we actually collected from over 2,300 families of ransomware, pretty much everything written to date. We've collected exact detonation artifacts. So we know what happens with each particular strain of ransomware, each family. And in cases, some kind of families have hundreds, sometimes even thousands of variants. So this allows us to identify precisely what happened to stuff that we have already seen. Then comes the second part. We use this to build a statistical model. And the statistical model uses several ML techniques also internally. It's fairly common nowadays. It's a behavioral model. And the model is a high-dimensional model. So it looks at lots of different things, essentially. So it is tuned on effectively everything that we have seen so far. So if you create any piecewise combination out of it, we will catch that. And the model is, for instance, more sophisticated than the deterministic model in that the requirement for the model was it should always be able to minimally cover everything the deterministic model does. So it's a layer of series of models, one behind the other. And this is very good at catching unknown ransomware with a very low false positive rate. Our original target was less than 5 false positives for 10 million files. And we want to give you actionable intelligence. We are not telling you your snapshot is bigger. We are telling you we found CLOP in this particular backup. This is your dirty backup and this is your last clean. So the statistical model is actually quite good in that it's false positives currently because we learned from it. It's less than 1 false positive per 10 million. And the reason for that is every time there is a finding that there is something malicious, we have an instant response team that looks into it. If it turns out to be a false positive, we let the customer know. And at the same time, the model gets updated. So the model is constantly refining itself now. And it is done quite well, actually. So as an example, in a typical week, we see about 25 to 30 ransomware families sort of deep in the dark web. They have not yet been released. They'll be coming in the next few months, so we might as well be ahead of the curve. So how well does this statistical model work, the behavioral model that we use? On most weeks, like 3 weeks out of a month, it'll catch all 30. Sometimes it'll miss 1. And in a very rare case, once every 6 months, we might miss 2. But in each case, the model keeps updating similarly in order to capture this behavior. And the third thing that we do is a form of overtime analysis, because in backups, you see a series of snapshots. So you have the history of a VM asset over time. And that allows us to do analysis by comparing operations that are happening between pairs and sometimes with longer chains, pairs to adjacent neighbor, basically. And this gives us much greater precision in being able to identify exactly what happened because our models are tuned to find all sorts of timing behavior that happens inside the detonation. The next part of it, the core of what we do essentially is post-attack recovery, being able to identify what asset is dirty, what asset is clean, and what was the last clean version. So this slide, we actually show some of the examples of what kinds of things people have done for anomaly detection. This is probably running inside your backup systems. But as I said earlier, they're somewhat crude metrics. The first one I described, the size of a snapshot. Now, a second more sophisticated anomaly detector is an entropy detector. So when you're measuring entropy, you're trying to figure out how random the data inside a file is. The more random it is, the more likely that represents the result of an encryption operation, and so it's encrypted. So this is measured in something called Shannon entropy. So the number is up to 8. It's one form of entropy at least. So it's a number up to 8. So encrypted files will be probably in the 7.85, 7.9 to 8 range, very close to 8. So if you find a file that has high entropy, you can assume that it got encrypted. If there is some pattern to it, you might say, hey, there might be ransomware active. But the problem with that approach is that there are several common files like PowerPoint that also have high entropy because internally they're compressed and zipped. And compression removes redundancy, so it makes the entropy go high. And it's well within the range of encrypted files. That's problem one. And problem two, folks like Logfile, what they do is partial encryption. And this stage is used by Royal and many of the ransomware gangs that came out of the Conti breakup. In partial encryption, what they do is, in the case of Royal in particular, encrypt 64 bytes, skip 128, encrypt 64. Others will encrypt every fourth byte. In either case, what happens is the entropy really doesn't change on the original. It doesn't look like an encrypted file. The entropy is in the 5s and 6s. That's fairly common inside a system for binaries also. So the net result is you can't actually tell. You can't even set the threshold correctly to be able to detect what these guys did. Zorist is another example. There are folks that look at the access time, last modified time to find patterns. It's not good enough. And that's because the things like Zorist don't change the metadata on the file. The file name remains the same after encryption. No extensions, no nothing. And the last modified time, last access time, all are pre-modification. So it doesn't look like anyone even touched the file. Alcatraz locker is another example. So a more sophisticated system for anomaly detection would do the following. It would look at a file, look at the header of the file, the extension of the file, and the contents of the file, and integrity check it. So if I expect to see a docx file, I expect a certain folder structure, and inside the main file, I expect to see a certain header in there, and the sections of the file have to match that. So you could do deeper file analysis to make sure file is consistent. If it is, then likely not encrypted. Unfortunately, what Alcatraz locker does is the following. It will take your doc file, encrypt it first, then base 64 encode that encryption, and then put an XML header on top of it. So now if you analyze the file, it reads as XML valid base 64 encoded binary XML file. And so you don't look any further. And so you have to double unpack in some of these scenarios. There are others that will actually slow the detonation phase. So they won't detonate in one big explosion and encrypt everything within minutes to hours. What they will do is small spurts, like 10 to 100 files at a time. So what ends up happening, and they're dormant for quite a while because they have a memory component that actually holds the decryption key. So net result, applications don't see that their IO is getting encrypted underneath. But when they attempt to read the data is fine because the key is still in memory. But the backup, on the other hand, catches that. It catches the encrypted data, and so your backups are getting corrupted. So these guys will dwell for a long time to make sure that your backups are corrupted to quite a decent distance in the past, to the point they're useless. Longest attacks in there are like 2 months. So if you lose 2 months worth of backups to encrypted data inside it, that is usually not a recoverable event easily. And so that is the kind of stuff you end up with. And finally, CryptoMix essentially encrypts a file name itself, making it very hard to match which encrypted file corresponds to what original. So these are some of the kinds of scenarios that we've had to deal with, less than a few of nearly 80 scenarios that are unique in there. Pass it back to Todd.
Yes, yeah, thank you very much, Srini. That was very, very helpful, very knowledgeable. I hope our audience found that to be very useful. I mean, it's amazing, these ransomware companies, they're out there innovating, building solutions, building software to steal and encrypt your data. And, we just have to, be vigilant against these threats. With that, I'd like to have Savath come and join us and talk a little bit about AWS backup and data protection and how the cloud looks at it.
Sure. Thank you, Todd and Srini. So Todd kind of talked about the larger landscape of ransomware, like the increases in threats, like what they kind of look at and then try to impact within your systems and all those things. And then Srini took us through the complications around why having a defense in-depth strategy is important to make sure that you have a good known response to any of these situations. So one important aspect that we talked about in this entire conversation was that backup should be treated as your last mile of defense, like your last standing defense that should allow you to do a proper recovery if everything else fails, kind of thing. But before we consider like the importance of backups, like what we can do to protect the backups and all those things, we have to understand in a systematic way what are the threats that would compromise your backups, which is prohibiting your recovery. So a good known approach that we kind of talk to our customers is about the Adam Shostak's 4-question framework, where we kind of look at each and every aspect of these threats that will stop you from doing a proper recovery. And then these are like, asking questions about what are we trying to, get on or work on, which is obviously ensuring that, you could recover from any kind of ransomware situation or a cyber event. But then we also have to look at what could go wrong. What are the threat vectors that could be trying to compromise? Like, are we trying to mitigate against an internal actor compromises, an external or ransomware that could compromise an entire AWS account? So all these threat vectors has to be looked at from every possible aspect that could compromise your recoverability. And then we try to figure out what are the mitigation strategies that we will be coming up with, which is very critical to understand what is the scope of the response that we are trying to come up with. And obviously, like any other model, you'll have to continuously evaluate what we are putting, because like Srini was mentioning, the threat landscape is continuously evolving, and they're not like kind of stagnant on their kind of approach into compromising you. So they are all evolving. So our kind of responses has to be evolving in such a way as well. So this is what kind of this question framework would kind of help you to define your threat model, which is what you would apply and come up with strategies to protect. So what we got to do is to look at how these things could be transferred or translated into an AWS backup implementation. Next slide, please. So why are we always talking about the importance of ensuring that you've got a clean backup, either through regulatory expectations or ensuring you're fortifying your response to a ransomware situation? So imagine, as you see in this slide, there's a 14-day backup retention period for your daily backups. And the backups in clean numbered 1 to 7 are your clean backups, which was like kept there. And if there was a fat finger error or a cyber situation that happened, then you could always rely on these clean backups to kind of do a safe recovery. Like Srini mentioned, if there was a particular malware that got through your XDR systems after they tripped and got into your source system, obviously backup being the copy of your source data, the malware also gets slowly trickling into your backups based on your daily written backup frequency. So the color orange, what would happen is that these are the backups which are impacted by a ransomware, not a ransomware yet, but a malware strain that's there. It is not yet detonated, which has not caused any kind of havoc in your data. So the good thing is that if you are able to detect base using a proper detection mechanism, to figure out what exactly is the compromise, not just saying that, okay, your backup is compromised or your data is compromised, but exactly figuring out what exactly was the compromise. You are now still being able to surgically remove those compromises and then probably able to recover your system, provided you kind of invoke all of your incident response and recovery mechanisms at that point in time. But when these malwares kind of detonate and then start encrypting your source data, that's when your backups also get encrypted and then your recovery options become depleted. So the intention is that the faster that you detect all these compromises, much before your backup retention window kind of still wipes off all of your good known backups, you will have to ensure that one that you could easily and in a much responsive way detect the compromises before they could even detonate. So that's why the timeline, the backup retention periods, the pace at which you kind of detect these compromises are very critical. Next slide, please. And I also wanted to introduce you to an industry standard, which is kind of followed by a lot of our larger enterprise customers. And we kind of call it the 3-2-1-1-0 approach of backups and their retention. So we kind of minimally expect that there is 3 different copies of your data, one including your production data. So if you're talking about a database backup, we would expect at least 2 different copies of your database backup. But the actual frequency of the backup, the retention period, everything will be kind of tied up to your data protection strategies. But we are talking about the actual number of copies. And it is always recommended that 2 of these 3 different copies are kept in 2 different storage mediums. But if you're thinking about a purely cloud-native cloud AWS deployment, we would be expecting that 2 different backups are kept in across the AWS account logical boundaries. And if you ideally want to be mitigating the risk of a regional failure, the one recommendation is to have one of these copies to be kept in a separate region, in a separate AWS region, in a bunker account, so that you would still be able to resiliently recover from a regional failure. Not just one, we ideally recommend all of your backup copies to be kept in an immutable storage, but at least one of these copies has to be in immutable storage. That's when things like applying service control policies or immutability logs and all those things come to play. But at the core of all of these different copies is what we call the zero, which is ensuring that all of your backups are recoverable. They are regularly tested. They are free from storage integrity errors and application integrity errors. And that's when these compromises that Srini talked about kind of comes into play, and ensuring that you don't get into this situation and your backups are clean when it's required to be restored from. Next slide, please. And I would like to introduce you to a service that AWS launched back in 2019, which initially came in as a simplification tool that allowed us to work backwards from customers' data protection requirements. So you would be able to define what we call a backup plan or a policy that would be capturing the essence of your frequency of backups, the retention period of your backups, your number of copies that you would want to maintain. And you define plans and policies, hand it out to AWS Backup. AWS Backup, in a simplified way, will be executing all these things on your behalf. But fast forward to 2023, 2024, AWS Backup kind of added capabilities in terms of not just allowing you to create backups, but also the second bucket of the recovery mechanisms, which is about ensuring your backups are indeed immutable in nature. So to Todd's point about 75% of the attackers will be trying to compromise your backup infrastructure. This is where the immutability extension of your backups are very critical. So we introduce capabilities like backup vault lock, which will allow you to define compliance mode logs to ensure that nobody, even your root user, cannot drop any of your recovery points. That's why these numbers are as of September 23 that 130,000 plus customers trust AWS Backup to protect almost 1.8 exabytes of their data. So in essence, this service kind of simplifies you to implement all of your threat modeling strategies that we talked about in the earlier slides. Next slide, please. So at the core of AWS Backup is a simple concept of a backup vault. So an AWS Backup vault is nothing but a logical container that allows you to group your recovery points or your backups. The intention of doing this grouping is similar to an Amazon S3 bucket strategy, where you can define your protection strategies at a vault level. So you can define things like who can create backups, who can access these backups, how the immutability aspects of this vault would look like. And when you apply things like backup policies, the recovery points will be created and stored and managed within this logical containers of the AWS Backup vault. And back in 2023, during reInvent 2023, we launched a capability called AWS Backup Restore Testing. To Todd's earlier point about all the regulatory bodies wanting to ensure that you just don't take backups, but also these backups are kind of clean and restorable. AWS Backup Restore Testing allows you to define plans and policies to ensure you're regularly testing your backups, and these testings are transient in nature, which means that you can define a plan, testing happens automatically, that data is captured and then kept with your recovery points. And overseeing all of these things is actually the observability component of AWS Backup called the AWS Backup Audit Manager. The AWS Backup Audit Manager allows you to run your entire organization-wide reporting to ensure all the strategies, whether it's about creating backups or testing the backups, they're all kind of complied to. And if there is any non-compliance, these are kind of got out through a compliance or a controlled compliance or a resource compliance report, which you can generate and hand it over to your internal and external regulators. Next slide, please. And just before reInvent 2023, we kind of launched a newer capability called the AWS Backup Logically Gap Vault, which is currently in public preview. This is the new type of vault. What this new type of vault does is 2 different things. One is ensuring that the immutability of the recovery points that was a choice that was given to users previously is kind of enforced from day one. So when you create a logical air-gap vault, you have to enforce the immutability by defining a minimum and a maximum retention compliance mode lock by default when you create the vault. And the second thing that we are introducing is the concept of a service-owned key. So you're probably all familiarized with AWS managed keys and customer managed keys, but this the encryption of the recovery point stored in a logical air-gap vault will be done using what we call a service-owned key. So a KMS key or CMK being a single point of failure in your recovery mechanisms will now be mitigated because those keys are owned and managed by AWS Backup as a Service, which means that the attacker cannot compromise it even if they get access to your accounts. But that's not all of it. The other major capability of AWS Backup Logical Air-Gap Vault is the simplification of sharing that we will be able to do using the integration with Resource Access Manager, AWS Resource Access Manager. So by defining a Resource Access Manager share, you will now be able to share the contents of this logical air-gap vault with any other account of your choice, either locally in the same AWS organization or an account outside of your organization. And we will see to how this is simplifying this entire restore testing and recovery process. Next slide, please. Okay, so we have been recommending to our customers on a strategy based on the threat modeling exercise that we talked about earlier, which is the workload account is actually an account in which your production data is actually hosted and then run. And based on the plan and policies, there will be local backups happening, kept locally in there. But depending on how much you would want to protect and how many copies that you would want to do, there's a notion of creating a vault account which receives copies of your data from all of your multiple different workload accounts. This is actually simplifying the concept of vault account, kind of further enhances your recovery mechanisms. So if you ever want to do a minimum viable company recovery using all of the copies from all of your crown jewel applications, you could do that from a single application account rather than having to go into individual AWS accounts. So now if you replace the normal vault in the vault account with a logically air-gap vault and with its integration with the Resource Access Manager, you will now be able to define a share in the vault account which will now be able to be accessed in an entirely different account. Let's call it a forensic account. The reason why we call it a forensic account is because this is where all of the safe detonation that Srini talked about can be happening, so that you kind of don't impact the testing with your production workloads. So a recovery point or a backup that is in the vault account now gets shared with the forensic account, and with the restore testing integration, you now will be able to test these recovery points for one, recoverability, and also integration with our partner like Elastio.com. So what Elastio does is that when a recovery testing is completed, with the simple integration of a notification to Elastio, it will be able to scan the restored temporary resources, whether it's an EBS volume, EC2 instance, an AFS volume, and an S3 bucket. It'll be able to scan the contents of these recovery points within the temporary retention period and let you know exactly, to Srini's point, that what exactly is the compromise both on a malware and a ransomware kind of method. So the malware tells you what are the detonators which are present in this one. So if you remember the slide on the timeline of backups, these are the yellow phase where the detonator exists but hasn't detonated kind of thing. But Elastio also has a second pass of scanning where it can tell you exactly what the compromise the detonation has cost, which is actually encryption of your file. So that way, again, you could still be able to do surgical removal of these encrypted files and probably recover from a previous version of this one. Next slide, please. So how do we put all these things together? I know this slide is a little bit complicated. We really want to do of this one, but if you first look to the left-hand side of the slide, this is where all of your tenant accounts or your workload accounts, however you're calling your production workload accounts reside. This could be in tens, hundreds, or thousands, depending on I work with customers who have got tens, hundreds, and even thousands in their accounts. Backup plan or a policy gets applied into this workload account. There will be backups happening locally. And these backup copies are your first copy, if you remember the 3-2-1-1-0 strategy. And based on a particular copy methodology, you might be copying the recovery point load accounts into your bunker account in the same region. This becomes your second line of defense, which is your second copy as such. And one common question that customers ask us is about what is the strategy in which you should apply these things. So you would be doing a more aggressive backup creation in your workload account, say an hourly backup. But the copy that you sent into your bunker account might be a daily backup. You don't have to send your hourly backups into your bunker account, which is probably a bit more, cost ineffective kind of thing. And then when you do a third copy into a bunker account in a different region, you can then decide to do a weekly copy rather than doing a daily copy. So the only difference is that your local copies kind of gives you that 1 hour RPO. Your copy in a different account in the same region gives you that 1 day RPO. But your copy in the different region, different account gives you that 1 week RPO kind of thing. But it's kind of staggered, but it also gives you recovery options. And it all ties back into the threat modeling that we talked about earlier. This is not all of it. Ensuring the zero is actually, again, the critical factor here. By having a forensic account, you will now be able to do the scanning of your recovery points for malware and ransomware through partner elastio.com. And the data that comes out from Elastio exactly tells you which file has been infected by a malware or ransomware. You could tie back the data either to a security hub integration or to your own reporting solution so that you could know exactly what was scanned. So when you utilize Elastio with restore testing, the good thing is that you know exactly out of all your recovery point lineage, what exactly was the testing done on, what was the status of the testing. So that way, whenever recovery is required, you know what is the last good known backup that you should rely on. That's how everything is put together. Even if it looks a little bit complicated, if you can apply plans and policies and all those things, it is very much simplified. And with the integration of Elastio with Security Hub and your own custom tools, like pager duties and all those things, it will be much more easier for you to manage. Todd, back to you.
All right, great. Thank you, Saba. I very much appreciate that. And it's interesting, as you go through this, the recovery testing and the forensics, that's where the compliance comes in, right? It's a best practice that's now being mandated through these organizations. And one of the ones, too, that we didn't talk about is, there's SOC compliance now that is looking to, really look at how you're doing this, as well as cyber insurance policies, right? Having filled more than one out, you can see what they want to know. Are you testing your backups? Are you recovery testing those backups? And can you recover from an outage? So, just as we kind of wrap this up before we get into Q&A, I think, when we talk about, whether it's compliance or just good data hygiene when it comes to backups, I think it's really important for everybody to have develop a clear and tested plan for recovery and business continuity. I think that's step one, knowing what happens when an attack occurs. What's the playbook? Have you run through the playbooks? Unfortunately, sometimes we talk to customers that the first time they go test their backups is after they've been hit. So that speaks to a regular, scheduled test and scan and recovery process. Elastio does a really good job of continuously doing that and automating those recovery tests, but you can also do more formal testing and just making sure that you get those done. Sabbath, thank you for talking to us today about AWS backup, and the whole vault lock capability and logical air gapping really just gives an additional layer of protection, keeping that data out of the hands of bad actors, right? With a set of AWS managed keys. And then training is always important. Does your staff have everything they need to battle the inevitable, right? And it's no longer a matter of if, it's a matter of when. And being cyber resilient is your best approach right now. Just a couple of takeaways. If you'd like to scan your data and your backups, please. There's a QR code. Feel free to take a picture and go download it. And also, there's a technical description of the AWS and Elastio integration. As we go in, we'll go ahead and start taking questions. Cecily, do you have any particular questions that have been posted?
Hi, yes, I do. I've got a question here that asks, can Elastio scan more than just the AWS backups?
So yes, our technology is agnostic to the type of backup. So we partnered with most of the major third parties. We're in their partner programs, and we can scan both on-prem and multi-cloud solutions. So yes, we can do that.
Thank you. I hope that that answered that very well. Oh, okay. So sorry, a couple ones are coming through. Do the Elastio scans impact performance?
They do not, right? Because they run in the backup, they're not in production workloads. And, just taking a page out of Trinity's book, it's very important for us to scan the backups because what we're doing is rather it can be intensive. So from a performance perspective, it does not impact production because these are done on offline copies or backups. And that's the other way that we can make sure that we ourselves are not being unhooked or bypassed by the ransomware or malware that could be present in those. So it does not impact production environments to do these scans.
Great, thank you. And I have one that is for Trinity specifically. So our team, backup size is definitely one thing, but like you mentioned, Trinity, what if there is just a minor change or a simple PowerShell script, which is injected in the recent backup, which does not really affect the size? How would that get detected?
Excellent. So the interesting thing is, we don't go do anything with respect to backup size. We believe that's a horrible indicator of anything. The most common causes for any changes, positive or negative, are usually benign. So in this particular case, the change, however minor, we still catch it. In this particular case, the PowerShell script that you injected, that is a file. We still see that as a file and we look inside it. More interestingly, you'll also find other secondary references, right? Usually there will be something in startup that will point to that PowerShell script. And most likely it's also sitting in a directory that is a bit suspicious, which is app data local roaming. So we have malware scanning capability that actually catches that.
Thank you. So I have another question that's come from the audience. So does Elastio run the scans after every backup or only during recovery?
We do it after every backup. So effectively, when we integrate with the backup system, we inventory all of the VMs in there and then allow a selection on a subset of them to be scanned. But as new backups are taken by the backup system, we automatically find them, scan them, and continue to report results.
Wonderful. And just so you know, Shundi, Samil, who asked the question about backup size, says, amazing, thank you to your answer. This is a good one. Does Elastio use any third-party AV for malware scanning?
Yes, we actually use a third-party AV engine in there for malware scanning. We use the Bitdefender engine, the same as our friends from AWS use with Guard Duty for similar reasons.
What's interesting is, the ransomware that we provide is unique technology in the marketplace and has been gathering a lot of interest. One of the things that we're very much surprised of when we do these backup scans is how many times we do identify malware that has been bypassed into the systems. In fact, it's running just under 30% of the scans that we do, which is surprisingly high. So I think, Srini, that speaks to some of the EDR bypass technology.
That's correct. It's ending up in the backups. It's not detonated, but the question is, it should not have been there in the first place, given even the first layer of defense in there. And yet it's fairly common, actually.
I have another question for Trinity. Where does Elastio find new ransomware to add to the model?
Tradecraft a bit. So a lot of sources, some of which are community sources, some of which are actually enterprise accounts that capture such things like VirusTotal. We work with the folks at VirusTotal in there for some portions. But then we also have our own folks in Eastern Europe in the right dark web places. Shall I put it that way? Which is usually the source of all the leading edge samples for us.
Great. I'll maybe give a couple seconds for people to send more questions, but otherwise, they've all been answered. This is your last call.
Well, everybody,
Great.
Look, I thank you for joining us today. Thank you, Trinity and Sabbath, for joining us. Very much appreciate your expertise, and hopefully this was valuable for all of our attendees today. Again, if you'd like to learn more, just go to elastio.com, or if you'd like to reach out to me to point you in a direction or to schedule some follow-up with Trinity, we'd be happy to do that. You can reach me at todd@elastio.com. I think I just saw one more question come in.
Oh, yes. Somebody asks if we will share the recording, and the answer is yes, we will share that.
Yes, we will be sharing the recording, and we will be posting it on our website, and we will send a note to everybody, to all the participants, that it has been posted.
Oh, sorry, I have a question for Sabbath. They were coming in last minute. So Sabbath, if we have a cross-account and cross-regional immutable backup configured with AWS Backup now, when AWS has come up with restore testing as well, is there an integration where Elastio can also use it and scan a restored machine? Or is it just scanning over an immutable backup?
Yeah, so that's the latest integration that we have done with Elastio. As in, like when I say latest integration, it is not the service integration. It is actually a component that you could deploy directly from Elastio, which will allow you to listen to the completion of restore testing events and then invoke a restore test. A scan on the restore tested temporary resource. Yes, so Elastio can do both scan and backup directly, or even scan your temporary restore tested resource as well. So both works right now.
Fantastic. And then we have a question about Elastio integrating with Azure.
That is currently in the works.
Cool. Thank you so much, everybody.
Thank you all.
Thank you, everybody, for your time. Very much appreciate. And if there's questions that come in afterwards, we will follow up via email. Thank you.
Thank you.